Our planet behaves like a very powerful machine, from moving incredibly big chunks of land to releasing enormous power trapped inside the beginning of time. One of Earth's biggest display of power is volcanic eruptions. When pressure builds inside of the Earth, it only has one way of being released: up. Volcanoes are a powerful destructive force, but it also is the engine that creates and modifies our world. In 1980, the world witnessed one of the most powerful volcanic eruptions of modern times, the eruption of St. Helens. This was a brutally violent release of energy that caused the death of several people, including one geologist, an expert in the study of this phenomenon, 6 miles away. This type of volcano that releases large amounts of energy in a very sudden manner. But not all volcanoes are violent like St. Helens. Hawaii saw its birth from volcanic activity many million years ago. The volcano of Kilauea is an actually active volcano that behaves in a very different way. It's a passive volcano that constantly releases its energy in a much more passive way. As we have seen, not all volcanoes behave in the same way. Just like different types of animals, volcanoes have some sort of personality. In comparison of these volcanoes, St. Helens showed a very sudden and violent eruption. It generated a blast releasing ash and dangerous projectiles. On the other hand, we saw Kilauea that generated a more gentle and quiet outpouring of fluid magma. The difference thrive in several factors of magma flow, including the rock's viscosity. Now, viscosity is defined as a fluid's resistance to flow. The more viscous lava is, the movement is slower and accumulates lots of pressure inside of the earth. Some of the factors affecting viscosity of lava is the temperature, the composition of the molten rocks, and the amount and nature of dissolved gases deep in the asthenosphere. Magma is a very serious threat to life. Volcanoes with high viscosity produce violent eruptions and expel a large amount of hot and toxic gas, besides ash that can directly affect the ability to breathe and can even block the sunlight, affecting complete food chains all around the world. In addition to eruptions, this can cause the collapse of surrounding area, destroying anything in its path. There are two very different lava flows. The Pahoehoe flow, it's a flow that generates smooth surfaces after drying. The other type of flow is the A'a flow. The flows are very rough with jagged blocks and spines, product of the volcanic ejecta. Here we see a picture of the Pahoehoe flow and the ropey structure it forms when they cool. In this other picture, we can see a comparison between the A'a flow and the Pahoehoe flow, the smooth surfaces of the Pahoehoe flow and the rough and jagged surfaces of the A'a flow. An incredible construct of the flows of lava under the earth is the lava tubes. This is a phenomenon that happens when Pahoehoe flow travels slowly, creating a tunnel of solid rock with the liquid movement in the center. After the outside rock cools, the liquid finally exits the volcano, and all that is left is a tunnel-like structure. Gases in a volcano are as important as the lava that flows from them. These gases are called volatiles and include a variety of different gases. There is water vapor, carbon dioxide, nitrogen, or sulfur dioxide. These gases can have several effects, not only on health, but also directly on our atmosphere and climate change. Other materials ejecting from the eruption are volcanic bombs. These are emitted as molten rock, are cooled in mid-flight after being ejected. When landing, they have the effect of a small lava explosion. The other projectiles are called pyroclastic materials. These are solid projectiles that are propelled by the power of the eruption of a volcano. For understanding volcanoes, it is very important to understand their anatomy. the flow begins in a magma chamber. The build of pressure causes a fissure on the crust where the magma begins its journey to the surface. The flow continues through a conduit or a pipe-like structure directly from that fissure. At the surface, the magma comes out of a vent or an opening at the top of the volcano. Now, some volcanoes have what we call parasitic cones, and these are side openings very close to the base of the volcano where lava pours after an eruption. Two terms that are often misused are calderas and craters. A crater is a small depression at the top of the volcano, while a caldera, it's a crater that exceeds a diameter of more than 1 kilometer. In the case of volcanoes, size do matter. We can have three types of different volcanoes. We have the shield volcanoes, we have the cinder cones, and we have the composite type of volcanoes. Shield volcanoes are produced by the accumulation of what we call basaltic lava. Their form resembles a warrior's shield. Here we can see an example of Mauna Loa in Hawaii and the warrior shield shape that it possesses. A cinder cone, it's also known as a scoria cone, and they are built from ejected lava fragments that harden in flight to produce a cone. An example that we have in here is the Paraticutin in Mexico. The last type of volcano is what we call a composite volcano, and it is a chain of volcanoes located in the Pacific Rim, better known as the Ring of Fire. That is all for our volcano class. Thank you for your attention, and I will see you on the next.